Consider the moving bicycle, or rolling of a coin scenario. We observe the following. If you consider a wheel, or a coin as a circle, and the touching surface, road, or table, as a line, the given illustration shows that a line touches a circle. In this case, the line is called a tangent to the circle. Let us now consider a circle and a line PQ. There can be three possibilities, as given below. Non-intersecting line, secant of the circle, tangent to the circle. Case 1. From the above figure, the line PQ and the circle have no common point. In this case, PQ is called a non-intersecting line with respect to the circle. Case 2. From the above figure, there are two common points, A and B, that the line PQ and the circle have. In this case, we call the line PQ as a secant of the circle. So, we can say that a secant is a line that intersects a circle at two distinct points. Case 3. From the above figure, there is only one point A, which is common to the line PQ and the circle. In this case, the line is called a tangent to the circle. The word tangent comes from the Latin word tangi, which means to touch, and was introduced by the Danish mathematician Thomas Finck in 1583. Tangent to a circle is a line that intersects the circle at only one point. Let us see what is point of contact. Point of contact, the common point of the tangent and the circle, is called the point of contact, and the tangent is said to touch the circle at the common point. To understand the existence of the tangent to a circle at a point, let us perform an activity. Take a circular wire and attach a straight wire AB at a point P of the circular wire, so that straight wire can rotate about the point P in a plane. Put the system on a table and gently rotate the wire AB about the point P to get different positions of the straight wire. In various positions, the straight wire intersects the circular wire at P, and at another point Q1, or Q2, or Q3, etc. In one position, we will observe that the wire will intersect the circle at the point P only. See position A-B of AB. This shows that a tangent exists at the point P of the circle. On rotating further, we will observe that in all other positions of AB, it will intersect the circle at P, and at another point, say R1, or R2, or R3, etc. This shows that there is only one tangent at a point of the circle. Now, have you seen a bicycle or a cart moving? Look at its wheels. All the spokes of a wheel are along its ready. Now note the position of the wheel with respect to its movement on the ground. Do you see any tangent anywhere? In fact, the wheel moves along a line, which is a tangent to the circle representing the wheel. Also, notice that in all positions, the radius through the point of contact with the ground appears to be at right angles to the tangent. We shall now prove this property of the tangent. Theorem 1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Proof. We are given a circle with center O, and the tangent xy to the circle at a point P. We need to prove that OP is perpendicular to xy. Take a point Q on xy, other than P, and join OQ. The point Q must lie outside the circle. Note, if Q lies inside the circle, xy will become a secant, and not a tangent to the circle. Therefore, OQ is longer than the radius OP of the circle. That is, OQ is greater than OP. Since this happens for each and every point on the line xy except the point P, we can say that OP is the shortest of all the distances from the point O to the points of xy. As we know that, out of all the line segments drawn from a point to points of another line, not passing through this point, the smallest line segment is the perpendicular to the given line. So, we can say that OP is perpendicular to xy. That is, the tangent at any point of a circle is perpendicular to the radius through the point of contact. hence proved. Remarks. By above theorem, we can also conclude that, at any point on a circle, there can be one and only one tangent. The line containing the radius, through the point of contact, is also sometimes called the normal to the circle at the point. Let's see some examples. How many tangents can a circle have? Answer: circles can have infinite number of tangents. However, at a given point on the circle, there can be one and only one tangent. A tangent to a circle intersects it in how many points? Answer: 1 point. A line intersecting a circle in 2 points is called a? Answer: secant. A circle can have parallel tangents at the most? Answer: 2. The common point of a tangent to a circle, and the circle is called? Answer: point of contact. A tangent PQ at a point of a circle of radius 5 cm meets a line through the center O, at a point Q, so that OQ equals 12 cm. Find the length PQ. Answer: given a tangent PQ to a circle with center O, and radius of the circle is 5 cm. Also given the distance OQ equals 12 cm. We have to find length of the tangent PQ. It is clear from the above figure, that OQ is the hypotenuse of triangle PQ. So, by applying Pythagoras theorem, we have PQ bar whole square equals OQ bar whole square minus OP bar whole square. PQ bar whole square equals 12 square minus 5 square. PQ bar whole square equals 144 minus 25. PQ bar whole square equals 119. Therefore, PQ is equal to square root of 119. Therefore, the length of the tangent PQ is square root of 119 cm.